The function y equal to sine x is not invertible, which means it doesn't have an inverse. Why? A quick glance at the graph of sine x, we realize that it fails miserably the horizontal line test. Therefore, y equal to sine x is not 1-to-1. Now, if we restrict the domain of sine x between negative pi over 2 and pi over 2, we will obtain a relation that is constantly increasing from negative pi over 2 to pi over 2, and that'll pass the horizontal line test. X will be between negative pi over 2 and pi over 2. Y will be, as usual, between negative 1 and 1, a full range. Now, we will need to create that inverse. And how do we create an inverse? Remember, to create an inverse, you must swipe y for x. It's the reflection over the line y equal to x. We get x equal to sine y. Now we need to undo sine y to get y, and that function will be inverse sine x. We take the inverse of both sides, inverse sine y. Undo sine y, so we'll get y. It's called the composition of inverse functions. If f and g are inverses of each other, f of g of x is equal to g of f of x is equal to x. So the inverse of x is equal to y, which we write y equal to sine, inverse sine of x. We can quickly sketch our new graph. X will be between negative 1 and 1, y between pi over 2 and negative pi over 2. And we just reflect that little portion over the line y equal to x. Here we go. Since we swap y for x, the new domain for the inverse will be x between negative 1 and 1, largely. And the new range will be the domain of the original function. Y will be between negative pi over 2 and pi over 2. The inverse function can be written as y is equal to the inverse sine of x, or y is equal to the arc whose sine is x. Both notation means the same.